Hi, everyone. My name is Daniel Moyer. I'm one of the sales support trainers here at Briggs Stratton Energy Solutions. Today, we're going to be talking about whole home backup featuring the EG4 Inverter Grid Boss line of products. Couple of housekeeping items before we get started. This is being recorded. A recording will be sent out to everybody who attends and registers, so take a look at your email after we're done. This course is not NAPCEP accredited. Next time we deliver this, I will have this approved by NAPCEP so I can issue credits. This time around, it's not. The chat has been disabled, but the Q&A is open and available to put in your questions. So pop in your questions as we're going along. Let's go ahead and get started. One exciting upcoming event, and one that I always look forward to every year, is the NABCEP conference. The NABCEP conference is a great opportunity to learn. There is amazing speakers from many different companies that present over the course of a couple of days. This year it's held in Milwaukee, which happens to be the headquarters of Briggs Stratton Energy Solutions. We are hosting an event the March 16th, so the day before the full conference starts. If you are interested, if you're going to be there at NAPCEP, let me know. My email is going to pop up at the end of this talk, and we'll get you an invite to come over to the Briggs Stratton headquarters, where we'll have a tour of our museum, presentations from some partners of ours, and then also one NAPCEP course as well. Lunch, breakfast, please be our guests. Let me know, and I'd love for you guys to join and show you what everything's about at Briggs Stratton. Speaking of Briggs Stratton, when I was growing up in the 1980s, I'm kind of dating myself. I remember mowing the lawn in my backyard in Concord, California, near Walnut Creek, California, with the Briggs Stratton lawnmower. If you look at kind of the statistics that we're showing on the page, most American homeowners at one point have owned a Briggs Stratton product and recognize that brand name. So when we think about the energy storage marketplace, there's a lot of newcomers to this market. There's a lot of names of companies I barely recognize when I go to the Intersolar or to the RE Plus shows. Briggs Stratton is one of those companies that has legacy. We've been around for over 115 years. And when we're seeing companies that are offering 10-year warranties, we offer a 15-year warranty on a 6.6 battery, you know that we're going to be around to support that warranty when the time comes. Now, when I learned that I would be working for Briggs Stratton after they had bought Simplified Power, who I was working for, I immediately thought back to that time I was mowing the lawn back in the 80s, seeing that Briggs Stratton logo. First time I went to Milwaukee to visit headquarters, I remember getting off the plane, getting in the Uber, heading out to the factory, and on the horizon, I could see this huge factory. In the horizon, I could see this giant water tower that said Briggs Stratton on the side of it. And I thought to myself, what an honor, what an opportunity to work for a company that has such a legacy of American manufacturing, and think about the generations of people that came before me. So I'm honored here today to be representing Briggs Stratton, to go to the future of energy storage and also generators, which we're going to talk about here on this talk as well. And there's a picture of that water tower. Again, if you're going to be in Milwaukee for NABCEP, come visit us at the headquarters and we'll be able to give you a tour and you can see that water tower for yourself. Well, let's jump into the EG4. Now, our partnership with SolarArc has been going for a number of years now. EG4 partnership was announced back at RE Plus in Las Vegas just a couple months ago, and I'm really excited about this partnership. We at Briggs Stratton make generators, we at Briggs Stratton make batteries, and then we leave it up to you as the installer to choose the inverter, whether EG4, SolarArc, GrowWatt, Mega Revo. We let you choose the inverter that you like, you're good and comfortable with. This talk, we're going to focus on EG4. Now, EG4 has a line of hybrid inverters, the 18K PV and the 12K PV that you see on the left. Those are very similar to the SolarArc 15K and the SolarArc 12K as well. But EG4 has another line, the FlexBoss 18 and 21, and then the Grid Boss that usually we pair with those Flex Bosses. And we'll get into why you may want to pair a Flex Boss with the Grid Boss and why you may not want to. These are really a game changer when it comes to having the flexibility of where to install a system, of having this centralized gateway or grid boss that allows all AC to come in and out. And I'll talk about the advantages as we get into it today. But I want to just talk about it, that 18K PV on the left, that has 200 amp pass-through. The ability to take in all 200 amps from a grid, from a home load, and pass it out onto the home load. 12K PV, that's 80 amps in and out. And then the FlexBoss 18 and 21, right? They still have the transfer switch or the MID, the microgrid interconnection device built in, but they only take in 90 amps. So that's why in a lot of situations, we are going to want to pair that FlexBoss with the Grid Boss. 18K PV can do 12,000 watts from batteries to load. It can surge, of course. 12K PV can do 8,000, and then the 21 can do 12,000 from batteries to loads, 10,000 for the 18K. And you can see these nomenclature that EG4 has used for the 18, 12. That's representative of how much DC coupled solar we can bring on these systems. Now, on the bottom, we're looking at our 6.6 stacking battery. Each battery module is 6.6 kilowatt hours. A full stack, which would be 3 modules in a single stack, that's the most you can do in a single stack, comes in just under 20 kilowatt hours, which is perfect for that NFPA 855 requirements of having increments in 20 kilowatt hours, and then cumulative capacity limits for certain areas of the house, like the garage or the basement. We get as close to that 40 or that 80 kilowatt hour threshold as we can. Another consideration, though, is the ability for a battery to discharge itself. Its C rate, how fast we can discharge a battery while not damaging it. With a full stack, right, a 3 stack of 6.6 batteries, the continuous output is 14,000 watts. So you can see here on the left with that hybrid 18K PV, we need a full stack of 3 batteries to support the 12,000 watts from batteries to loads that hybrid inverter might be asking for. A 2 stack can supply 10,000 watts, 10,600 watts to be precise. So you can see with the 12K PV or the FlexBoss 18, that can only do 10,000 or 8,000 watts from battery to load. So that's the minimum number of batteries you're going to want to pair with these inverters so that if the inverter is ever called upon to output its maximum output from batteries to loads, you're not going to be overloading the battery. The idea, though, here is that's the minimum, and there's going to be a lot of situations and applications where we're going to want more energy storage capacity than just a 2 battery stack that you see there. Grid Boss on the far right-hand side, 200 amps in, 200 amps right back out. It has the 125 amp generator input. Smart load outputs, we're going to get more into that here in a second. So when we're looking at the 18K or the 12K PV, we got that kind of as the hub, right? That's where the transfer switch lives. We have grid usually coming into the system to charge up the batteries, keep the topped off. If the grid goes out, the microgrid interconnection device, the transfer switch built into the inverter will automatically disconnect us from grid. We can then use energy stored in the batteries to support the home's loads. Perfect for an outage, perfect for situations where generators can't be installed, maybe due to HOA requirements, lot line limits, or maybe even the home doesn't have any gas coming to it, propane or natural gas. Of course, in a lot of situations, we are going to bring in DC coupled solar through the charge controllers to charge up those batteries during the day, discharge the batteries to the home loads at night. That's especially useful when we're in a state or a utility that doesn't allow net metering, which is becoming more and more common. We used to have net metering, the ability to use the grid as our battery. We could export to grid earning a 1-to-1 credit for every kilowatt hour we export, use up that credit at night or in the winter, and then have an annual true up. The reality is that in a lot of states, most notably Illinois right now, that idea of having net metering has gone away. We've gone to a net billing tariff, which means that we can no longer export and receive full credit. We get a wholesale credit. So we're going to want to implement these batteries into solar photovoltaic systems for municipalities, places where we don't have net metering anymore. We can bring in AC coupled solar. This is great for coming out to a site that already has maybe some N-phase microinverters or a solar edge string inverter. Bring it into the gen port on these hybrid inverters. When the grid goes out, the inverter disconnects us from grid using energy stored in the batteries. Again, can power the home load, but also create a microgrid in the home that the AC coupled solar just recognizes as grid and will continue to operate. When the batteries start to get full, the loads are satisfied, we can use frequency shifting to adjust the AC sine wave to start to curtail some of that AC coupled solar. Now, with the 18K PV, it just has that 1/3 input, the gen input, right? We got our grid in, load out. Well, the grid could also be an out if we want to send back to grid. And then that gen port. The gen port really can only be used for one of three things. The AC coupled solar, like we're showing, we could bring a generator in using 2-wire signal to start. We can start and stop that generator based on the state of charge of the battery. Or we can use it as a smart load output. So you kind of get either or. You can't get all three. That's where the GridBoss FlexBoss combination comes in together. Now we're going to jump into a little bit more single line diagrams here in a second, but we got something very similar here where we're set up. Grid coming into the gateway, then flowing to the inverter and the battery, right? The grid can then send AC down to that inverter. We can act like a battery charger, turning AC to DC, or it can turn that DC to AC, an inverter, and send it up to that GridBoss, going to power the home's loads. We can bring in DC coupled solar like before. We can bring in AC coupled solar into that GridBoss. And at the same time, we can bring in a generator as well. The idea is that we also have smart load outputs. That GridBoss is giving us the flexibility to add all of these sources without having the need to choose between one or the other. There's another great advantage, the flexibility of install, which I'll get into in a little bit later. Any questions, please pop them into the Q&A. Let me know if you've done one of these systems or why you might like EG4. Another reason I like EG4, specifically the FlexBoss, is that they're sealed. There is still fans, but the fans are just blowing across heat sinks that are external to the cabinet of the inverter. So there's no way for dust and dirt to get into one of those FlexBosses. Also, the way they designed, EG4 designed the FlexBoss is that it can fit flush up against a gutter, a wiring trough that's directly underneath the FlexBoss. That means you don't have to do the little stub conduit going down into a gutter. Really nice. I like that feature, although you still need to have some space on the sides and the top of the FlexBoss 21 and 18. With the 18K PV, a little bit different design, and we do need to have that air clearance on the bottom to vent out. GridBoss, again, though, it has the no clearance limits on the bottom. Also, the GridBoss has knockouts on the back side of the cabinet. So if you really want to get a nice clean install, hide all the wires inside of a wall, you absolutely can do that with that GridBoss knockouts on the back side, which I really like. You may have noticed that the FlexBoss 21 and 18 don't have a screen. They do have some LED lights. The 18K PV and 12K PV do still have a screen. I kind of like a screen. I'm kind of that more old school where I used to go out to the Power Shack and look at the Trimetrics battery meter or take a look at the different displays on that trace inverter. There's a lot of homeowners out there that maybe feel like me where they still want to look at a screen. They don't want to work through an app. they don't want to work through some laptop to monitor the system, there is an option to add a screen to the FlexBoss 21 and 18. That's what you're seeing here on the screen. It is an accessory, costs a little bit extra, but you can add that to it. You can do all the programming and monitoring right through these screens. Another accessory offered by EG4 is the ability to hardwire Ethernet internet over to the inverters. I think that's a great way to build a more robust system. Inevitably, you have homeowners that change their Wi-Fi password, get a new router, all of a sudden their system is down. We used to have a lot of end-phase systems that happened. They would just go offline. Well, when you run Ethernet cable out there and somebody replaces their modem, they're just simply going to unplug all of the Ethernet cables they see coming to it and plug them back into the new one. It's also great when you have weak Wi-Fi signal or a property that's very large and you can't get that Wi-Fi signal all around the property without having to use those little Wi-Fi extenders. Great option. I recommend it. Of course, you do have to run that Ethernet cable to wherever the inverter may be. Well, let's jump into some of those single line diagrams. So we're going to start with the 18 kPV. On the left there, we got our grid, we got our meter socket, we got our main load center, and we got it flowing into the grid port on the 18 kPV. Coming out of the 18 kPV, we're going to our critical loads backed up panel. You may be able to move all of those loads from the load center down to the critical loads backed up panel. There's a lot of situations where they already may be moved. A lot of people have either underground or overhead service coming into a meter socket to a disconnect, and then elsewhere in the house is that loads panel that's already been populated with the breakers. So we absolutely don't need to relocate anything. We can go ahead and just back up the entire system. Also there is the battery and the DC coupled solar. Now I like EG4 said that the critical loads backed up panel is optional. You could install a battery with one of these inverter systems and not back up anything. You could be using it to do time of use arbitrage. The DC coupled solar is optional. You could absolutely have a backed up loads panel and still do battery backup without solar. And that's becoming more and more common. It always, confused me why somebody would want to do that, but there's some people that just don't want solar. It's too shady. Maybe their roof needs to be replaced, and at this time they can't do solar. They can still participate in the backup resiliency that a battery gives them. They can still participate in the time of use arbitrage if they have time of use rates. They don't need solar. And, frankly, they don't need to back up anything as well. Now, that being said, if you're already out there doing a lot of this work, you're going to move some backed up loads. A lot of times I like having the idea of a small DC coupled array anyway. Off-grid. Absolutely, off-grid is warranted by our generators when combined with an energy storage system. EG4 had a lot of their roots in off-grid, and our batteries are warranted for off-grid as well. 18 kPV is a great option for off-grid, but they also make a line of off-grid inverters as well, dedicated ones. But I really like the idea of using the FlexBoss 21 or 18 for off-grid systems. We're looking at the right-hand side there now. We don't need 200 amp grid pass-through because we don't have grid. We can still use the FlexBoss 21, use the load output, bring a generator in, have that load center, right? We're backing up the whole home here, a battery, and of course we're going to need that DC coupled solar if we are off-grid as well. Another example there is the FlexBoss being used in a partial home backup situation. Very similar, but we're not going to be able to bring in all 200 amps. We're going to want to use a backfed breaker on the bottom of that load panel with the hold down kit, where we're only going to be able to bring in, we could maybe be able to put in a 90 amp breaker, and using PCS CRD control, we can put in a larger breaker than say a 40 amp breaker that would typically be allowed on a 200 amp panel with the 200 amp bus, meeting that 120% rule. So Definitely flexibility, but I think where most of the flexibility comes in is when we bring in the grid bus. We'll take a look at questions really quick. A question a little bit about changes to our battery. So, you know, our battery, the 6.6 battery, is a great battery. And one thing I really like about Briggs and Stratton is that American company is truly going to be able to bring a lot of future products to American manufacturing, bring them back to the United States, where we can be fiat compliant. The batteries that you see, the 6.6 batteries, absolutely are being sourced where we can control where we get the cells, where we construct them, and how we're able to provide that fiat compliance as we look to the future of what it's going to be like with the IRA, right? The 30% tax credit going away. So stay tuned for some of those updates. Tech support, right? Working remote is going to be there to help you out as well. So we're looking here with the optimized system on the left with the grid boss, flex boss inverter with the grid boss. And as I showed earlier, it has the ability to bring in AC coupled solar, backed up loads, non-backed up loads, smart loads, and also the generator. And we'll jump in here to a second really quickly, what it's going to look like when we start to leverage a grid boss, how that makes systems easier, cheaper, and faster to install as well. On the right, we see a multi-inverter system that's coming into that grid boss. That is the key, really, because there's a lot of parts and pieces that grid boss offers when we compare it to, say, a Solarc, for example. And I'll show you what I mean by that right now. So there's a lot going on this screen here, but what we're looking at is two paralleled Solarc 15K systems. In the top right corner, we have grid coming through a utility meter, going into a disconnect. Then, in order to operate parallel connections, the output of grid needs to be combined. And this would be one load center here, L1, L2. So we have to have a load center to combine up grid. We have to feed that grid into both of the Solarcs. Coming out of the Solarcs, out of the load port, we then have to go into another load center, combine up their L1s and L2s there before we can finally flow out to our main service panels. This bypass switch really is a great option and a great idea because if the inverter system ever fails, we can simply bypass the system, taking grid, making it flow directly into the load service panel. Another piece of equipment. If we have a generator here and we want to power the Solarcs, we have to combine the L1 and L2 of the generator in a load center and feed it up into the generator ports. Likewise, if we have the batteries, we have to have a single battery bank that's combined that then flows up into all of the both of the inverters. A lot of extra conduit, combiners, wire that you're seeing on this slide here, and a bypass transfer switch. That's the key with the grid boss. We have multiple inverters here. The combiner for L1 and L2 is in the grid boss. We don't need anything external right here. We're able to feed the batteries to the individual inverters. The grid bypass is built into it. We don't need to have an external bypass right here. The ability to have in a generator here with the 125 amp input, that's 30,000 watts, is here. We don't need to combine it when we have multiple inverters because it's all built into that grid boss. I absolutely love Solarc. I think the Solarc 18K that just came out is a great option for systems where you might have historically in the past had to do multiple inverters. Now you can use that Solarc 18K to do everything with a single inverter. But there is situations where we're going to need multiple inverters. If that's the case, using the Grid Boss FlexBoss 1821 combination is really going to help you out here by having it all centralized in this AC in, AC out kind of architecture. Non-backed up loads can still land here. We can bring in AC coupled solar, and we have smart loads that we'll talk about here in a moment. Before we do, let's just talk a little bit about our battery, the Simplify 6.6 stacking battery. Each module, like I mentioned, is 6.6 kilowatt hours. We stack together, goes together really quickly with these alignment tabs that you see in the right-hand corner. Every system is going to need the following components. You're going to have a stack of batteries. You can go up to 3 batteries in a stack. You can have up to 6 stacks in a system. Each stack is going to need to have a controller on the top. This is where the power button is. This is where the fuel gauge is. And this is where the home runs come out of the battery stack and flow into the inverter. That's the power and the communication. That's letter A. Below the controller are going to be our battery modules. At the bottom of the stack, we need to have a base. Now, we have one base that can either be function as a wall base or a floor base. So not only does it provide that physical support for the structure of the battery, but also it has the terminating pins for the closed loop communications. You're going to have an inverter. Again, we offer mini inverters. Today we're talking about EG4. Then we have an optional energy track. And I'll talk about the energy track here in a second. The batteries stack together. Not only do the power stack together, but also the communication stack together through this rapid stack connector pinout. They're all held together with alignment tabs, and there's little screws that hold it together. It is outdoor or indoor rated. I really like the look of the battery. You know, looks matter. We as installers will just throw a battery up and run back to the truck, run back to the van, but a homeowner has to look at this thing for the next 15 years or so. Looks matter. Also, being able to lift it up off the garage floor. You know, there's lots of, I'm sure we've all seen the customer's garage full of stuff. Getting it up off the floor makes it a lot more flexible for a homeowner. 15-year warranty on this battery, unlimited cycles, 100% depth of discharge with no throughput clause. Now, although we have unlimited cycles, we do have some estimated cycle life based on the rate at which you charge and discharge the battery. 0.5 charge rate, that's a 2-hour charge rate, C over 2. So if you charge the battery in 2 hours or discharge the battery in 2 hours, you can expect 6,000 cycles. If you're hammering on the battery a little bit more, an hour and 15 minutes charge, discharge, you're going to get a little bit less cycles. Although we say 100% depth of discharge, I recommend an 80% depth of discharge just to leave a little bit of juice in the battery. We're leveraging that lithium iron phosphate chemistry. So energy track, I mentioned it before. Of course, EG4 has their own app. So does Solarc. Most of the homeowners are going to interface through the inverters app. Same with the installers. But we do offer our own piece of hardware. We call it the Energy Track Gateway. And then we also have our own software, all housed here in servers in the United States, the Energy Track app, that now just recently launched for our generators as well. So why would you want another app, or what's the value here? Well, one thing this device and app offers is that it communicates more directly with the battery. What I mean by that is, of course, the battery and the inverter are talking to each other, and the battery is transmitting a lot of parameters to auto-populate set points in the Solarc and EG4 inverters. It's battery temperature to maybe do cold weather curtailment if it gets there. Our battery can go down to 14 degrees ambient, which is a lot of our competition's 32. But when you add this device, it really gives you a higher level resolution of the battery parameters and also notifications, which can help you with tech support. Our tech support can obviously remote into the MySolark and the EG4, but they can also remote into this device, looking at your system and help you quickly troubleshoot any issues that may be happening with the batteries. As an installer, you still get fleet management. The customer still gets access to this. So if you got one of those high-techy customers that really likes all of the details, information, this might be an opportunity. It can automatically update the battery's firmware over the air, has cellular, Wi-Fi, Ethernet, and you can use Bluetooth to commission it. That last point, future ready. There's a lot of things built into this piece of hardware that aren't being leveraged right now. The idea that we're going to have distributed generation on people's homes, solar, that we're going to have distributed storage, batteries on people's homes, and how that is going to interact with the wider grid really depends upon microgrid controls or the ability for utilities to communicate with devices and control maybe when a home off-grids itself, maybe when a home discharges its battery to grid, maybe when a home can island itself, right? Like I mentioned. So a lot of those functionalities is going to be communicated through a device. That device is the energy track. So there's a lot of things to come to really future-proof a system and be able to participate in a lot of these programs. VPP, demand response, that's where this energy track gateway is going to come into play. When we're wiring the energy track gateway, we're going to come out of the inverter, out of the back can, flow into the energy track. Out of the energy track gateway, we're going to flow down to the batteries. If we have a site that's not going to be leveraging the energy track gateway, we're going to come directly out of the battery controller on the top of the battery. That's what you're looking at of a side picture here. Out of the CAN port, through a crossover dongle, directly into the inverter, and we're going to have a terminating resistor in the last battery in the stack, or in the first battery if there's only one stack, to close off that closed loop communications. You know, thinking about working with EG4, I had a couple of questions, and I was just curious. All of these systems need to have rapid shutdown buttons, right? So that if the fire department emergency responders show up to the house, they're going to kill power to the house by flipping off the main breaker, maybe taking their fire axe to the meter and knocking it out of its socket. But if you have an energy storage system on site, loss of grid only means that I need to turn myself on using battery and start powering home loads using the battery. So we still have live conductors in the home while the firefighters are there. Code requires that we put an emergency rapid shutdown switch in a readily accessible location so that if the firefighters show up, they can hit this button, which will shut off the output of the inverter. Now, there's a lot of inverters out there where you got to install this separate button. It's usually normally open, and then when the button is pressed, it closes that circuit, shutting off the inverter. EG4 inverters have this built into them. The EG4 18K PV, also the Grid Boss has it built in. Now, you want to check with your AHJ. A lot of times they're pretty picky when it comes, or the fire department, when it comes picky to these buttons, and they may not like it kind of on the side where it says RSD stop. They may want kind of something that you see here. So absolutely, you can still wire that in. Also, if the inverter happens to be in a non-readily accessible location outdoors, you're going to want to go ahead and include this where the firefighters can find it during an emergency. Notably, the Grid Boss can also remotely shut down multiple inverters when the communication system wiring has been correctly done on that Grid Boss. You know, I had another question is, do any of the EG4 inverters have a service rated entry disconnect? Our transfer switch is due on the generator side. The 18K and 12K PV do not, but the FlexBoss does have a service rated entrance disconnect. Now, right out of the box, the Grid Boss does not come with this breaker. You got to go down to the supply center and buy the breaker. It's pictured on the right hand side, but you can insert this here and have it be the service disconnect. Couple of notes though, again, check with your AHJ or the utility. A lot of times they still like seeing an external disconnect. And I'd also say a lot of times when we're coming out to homes, they already have a meter, they already have a disconnect. So we might want to just go ahead and leave that in place and just feed that right into the grid port right here. But on a new construction, some other applications, absolutely we can bring in the service and have the disconnect built into the Grid Boss. If you're going to do that, remember that we only want one neutral ground bonding location in a home at the place of disconnect. So if you are going to install this breaker, they do include a bonding jumper that allows you to bond the ground and the neutral together inside of that Grid Boss. Make sure you read the manual carefully. I got a little snippet here, but just make sure you understand what you're doing when you're making this a service rated disconnect. Another thing I asked, does that Grid Boss come with hold down mechanisms for the breakers? Again, this is in code. So if we have a backfed breaker coming from an energy storage system, if the grid goes down, and we're in a critical load subpanel, well, the hybrid inverter is going to disconnect us from grid, and we can use a backfed breaker to backfeed a load center. We might also come down on a lugs, but if we have the backfed breaker, that's live. Even if you were to turn it off and pull it off of the load center. So by code, we have to have a hold down mechanism. I like to think of it as you got to really try hard to get electrocuted. And a lot of times with the Eaton breakers, it'll be a little screw that holds down. But inside the Grid Boss, that hold down bar that you see there highlighted on the right-hand side is already included. Not another need for another part. The 18K PV, as I pointed out, has that, and the 12 has a third port, the gen port. Can be used to bring in a generator, AC coupled solar, or it can be used as a smart load output. Notably, though, if you're going to use the FlexBoss Grid Boss, and you can actually use the 12K and 18K PV with the Grid Boss, the smart load output cannot be used. You got to use the smart load outputs inside of the Grid Boss. Let's talk about those smart loads inside the Grid Boss a little bit more. This is a great feature for a couple of reasons. One, when we start to look at some of the NEC code when it relates to sizing these energy storage systems, NEC doesn't specifically say you need a certain amount of kilowatt hours or amount of energy or how many batteries you need in the system. But code is starting to talk a little bit about how large a system needs to be able to power the loads. Some of the older versions said that you only need to be able to power the single largest load in a home. Some of the newer codes, though, are starting to reference that you need to be able to back up an entire home's loads with one of these energy storage systems. One way to get around that is using load shedding capabilities. And the Grid Boss has that built in. These smart load ports they have a couple of different logics that we can use. One of the simplest ways is that if the grid is lost, no grid, the smart port will automatically turn off, right? Grid's there, we're going to allow power to flow through that smart load. But if grid is lost, we're going to shut that load off. It might be a pool pump, a pool heater, something we're not going to need in an outage. We can make them a little smarter than that. We can have the smart load be based on the state of charge of the battery. This is something, right? When we lost grid, we're an off-grid home. And that was something I always would educate my off-grid homeowners is that imagine it's after noon, right? The sun's been up for a little while. The batteries are fully charged. The solar is producing. All of the home's loads are satisfied. That solar is being curtailed. It has nowhere to go if the batteries are charged and the loads are being satisfied. So go ahead and turn on some of those loads. Go ahead and do the laundry or use an electric appliance because that solar is otherwise being wasted. And that would require an active kind of monitoring of the battery level and actions, whereas these smart ports can do that automatically. That grid boss knows the state of charge of the batteries and can automatically turn on and off loads based on that state of charge. When the battery is full, let's turn on a water heater. Let's turn on the EV charger. Let's use that solar while it's available. When the sun goes down and the batteries start to drop, we can turn off that EV charger or turn off that water heater, which is going to retain that hot water for showers later in the evening. So a lot of ability to operate that. I've linked here kind of the model, the Grid Boss manual, so you can jump in there and understand that a little bit more as you try to optimize some of these things. Talked about this already, but I always like the idea of a manual bypass on energy storage systems. It allows you to service the system. If it's broken, it allows you to bypass it. And having that manual bypass is a great feature. There's two large breakers inside of this Grid Boss, and there's a breaker interlock kit that allows only one of these to be turned on at a moment, which allows you to bring in grid, flow down, and flow into the backed up loads panel. And if you look carefully at this diagram, it also continues to feed any of the non-backed up loads panels as well. One reason I think that EG4 is one of the best manufacturers on the market for integrating generators is one, that 125 amp input on the Grid Boss. But here's the other one. With some of the other hybrid inverters on the market, you can set the start percentage that will signal the generator through a two-wire signal to start, right? Battery is getting low. Maybe it's down to 20%. Let's start that generator. Let's use a generator to charge up the batteries and support the loads in the home. Once the battery is full, the generator will shut off. With other inverters, unless you do some advanced programming through the time of use settings, that generator is going to run all the way till it's full. The generator is going to run a long time. With EG4, they have the ability to set the end state of charge for a generator run cycle. And here's my example. Let's say it's evening. The batteries are low. The batteries aren't going to make it through the night. Let's go ahead and start up that generator. Let's maybe get the batteries up to, say, a 50% state of charge, and then shut the generator off. I don't need to run the generator into the wee hours of the night to get a full charge because I know in the morning the sun is going to come up and fully charge those batteries back up again. So that's a small thing, but I think a very powerful thing is the ability to not only start a generator based on a state of charge, but also stop a generator based on a certain state of charge. And again, it is available through Solar, though you just have to do it a little bit differently through time of use settings. Another reason I really like the Grid Boss for generator integration is when we have AC coupled solar. I mentioned earlier that we use a microgrid formed by the inverters powering the Grid Boss, powering into the Grid Boss to create a microgrid, and we can use frequency adjustment. One issue you get, though, is when the grid is present, the inverters become grid following. which isn't a problem because AC coupled solar can be backfed to the grid. But when we start up a generator, the inverters become grid following as well. Not the inverters aren't grid forming anymore. So when we have AC coupled solar and we are running a generator, we lose the ability to curtail AC coupled solar using frequency adjustment. One way we've historically done this in the past is we could maybe program the generator to only run at night. We could install a relay, which would open up the AC coming from the AC coupled solar so that when the generator was running, the AC coupled solar would not be producing. The grid boss has that built in. We have that relay right here. When that generator starts, it's going to come up, power all backed up loads. It's going to start feeding power back to the EG4 inverters with the batteries, which would be right here to the left of them. And it would open up these smart ports so that we're not allowing the AC coupled solar to recognize the generator sine wave as grid and start to backfeed that generator. Any questions, comments, please put them in the chat. Here's another reason why I think the grid boss, flex boss combination really makes a difference in your installs. And although you're having to buy two pieces, a grid boss and a flex boss, it can actually make it less expensive. So here's a home, right? We got a transformer up on that pole. We got overhead service coming down into a meter socket to a disconnect going into the home into a load center. We can easily come in, intercept the service conductors, taking 200 amps, feed it into that 18K PV under the grid port, have it come off the grid port, flow into the load center. We got our batteries there, nice and easy. We can put it all kind of out there wherever the service is, right? We want to keep this stuff close, no problem. Let's say the load center is on the other side of the house. Well, that's okay. We can still put the 18K PV in the batteries. We're just intercepting that existing conductor, the existing wire that's already there. We're not doing much or adding much. We could possibly even put the 18K PV in the battery out by where the load center is. Again, all we're doing is intercepting the existing service. Now let's think about this. Now, if you notice, the window and the door moved over a little bit, so we don't have room to put the battery where the service is or where the load center is. We have room for an inverter out there. So what do? Well, we could keep the inverter outside, run the 200 amps into the 18K PV, 200 amps right to the load center. Then we could use really thick battery cable and pipe it all the way over to wherever we want to put the battery. Maybe it's 100 feet away. Maybe we also want to put the battery inside a garage for cold weather. That's really expensive. Not to mention that we're going to get some voltage drop on that 48 volt nominal cable because we don't got a lot of pressure going through it. I wouldn't recommend that. If I had to, this is probably what I would do, is bring 200 amps out of that disconnect, run the entire home's loads all the way across the house, feed it into the 18K PV, come right back out and go all the way back over. We just added, hundreds of, maybe even $1,000 worth of cable to do this, let alone all the labor as well. This is where the grid boss comes into play. We can put that grid boss outside, right next to the service, right next to the load center. Instead of having to bring 200 amps over, 200 amps back, we only need one set of L1, L2 neutral ground going over to a FlexBoss 21 or a FlexBoss 18, because we're only sending 90 amps most between the two. We're really saving a lot of money, a lot of labor when it comes into doing something like this. And you don't need that disconnect if you're using the grid boss as your service rated entrance. talked about this already, but the ability to also parallel up multiple inverters makes it a lot easier. Monitoring, absolutely available. EG4 not only has a web-based monitoring platform, but of course they also have a mobile-based app that allows you to monitor the systems. A lot of detailed information in there. You know, we make batteries, as I mentioned earlier. Briggs Stratton makes batteries, and we partner with other inverters. We don't simply just make a battery and say you can use it with anybody's batteries. You technically can, and if you get the programming right, it'll work. Um, but if we're going to say we work with somebody else like EG4, we're going to make sure that we've done a lot of testing through the engineering department, that they understand all of the implications come with the CAN bus communication. We're going to make sure that our tech support is able to support you. We're going to make sure that training can do that. And we're going to make sure we have documentations there to help you do a successful integration, whether it be with Solarc or in this example, EG4. And one way we do that is we don't just publish an install operator manual for the 6.6, which you see on the right-hand side there, but we also published an integration guide. And this document specifically walks you through the steps to combine a 6.6 stacking battery with an EG4 system to physically make the connections and also to program the settings for a battery backup scenario. That's where we want to be, is support these integrations with more than just saying, go ahead and do what you want. We want to be here to be able to support that and make it successful and easy. Couple other reasons I like EG4. They have EMP hardening built into their systems. I would say that our batteries are not EMP hardened. So you're going to want to do like a Faraday cage or something around the batteries as well. But this is really cool. On some of the competitors, it's an added feature that you have to pay for extra with. Another cool feature is this weather optimization function. So the idea here is that the EG4 app will know what the weather forecast is for the install location, and then take actions based on those weather forecasts. For example, if a big storm is coming in, it will know that, stop discharging the battery, maybe to do a time of use arbitrage, charge that battery up fully, and then keep it ready for an outage if it does occur during a storm event. Pretty cool. As we're wrapping up, I just want to mention some of our promotions. If anybody on this call has not installed one of our systems yet, we have an offer for you, $1,000 off your first install, whether you do a Solarc or an EG4 inverter with a full stack, right? A 3-stack of a 3-module, single stack of batteries, $1,000 off. Just simply upload your proof of purchase from wherever you bought the battery onto a form on our website, and we'll cut you a check for $1,000. If you do another system, I noticed that these rebates are ending quickly. Stay tuned if we're going to renew those. And if you do that first one, let me know, and we'll make an exception. The second one, right, ending at the end of the year, we'll give you another $500. Once you're in the program, or once you've done your first install, we'll let you into the IQ installer program, where we'll offer $100 off every battery you install, no minimum amount of battery, and we'll cut you a check on that. Additionally, there is some social media advertising credits. Reach out to me. I'll make sure that we get you some of information on that as well. So why do an EG4 over a Tesla, an Enphase, or a Franklin? One, we can do both AC and DC coupled solar. Some of those actually can do that now. We can easily integrate generator, 125 amps input. Scale, right? We can easily scale. We can add more inverters and batteries. We can do that off-grid, warranty on it. And we really have that short lead times as well. I'm looking at that picture on the right-hand side there, and I'm thinking, why would somebody do our batteries instead of an EG4 battery? Right? EG4 makes their own batteries. I could think of a few reasons. One, we have a 15-year warranty. Two, we have the ability to be more modular in the amount of stacking, right? The EG4 batteries come in 15 or 16 kilowatt hour increments where we scale at 6.6. We can get a little bit closer to those NFPA limits. And so for example, we got 40 kilowatt hours in a storage closet. If I had a EG4 battery, I can do two of them. I get right around 30, but I could also do two stacks of simplified 6.6 and get right up to that 40 kilowatt hour threshold. Our batteries can do ambient 14 degrees temperature ambient without the need of battery heaters as well. Also, the name brand is going to help you make that sale. There's my email, energy storage training at basco.com. Tech support if you need them. Please put in any questions as we're coming to an end here. Where can we purchase your products? You can purchase our products at any of the major distributors. Green Tech, Solagent, Northern Arizona Wind and Sun, Baywa. I'm going to get in trouble if I forget any of the good ones. EcoPro Solar. If you're out on the islands, Inter-Island Solar Supply. Any of the major distributors will be able to carry our products. Those rebates, all you got to do is upload that proof of purchase from the distributor that you bought it from, and we'll cut you a check. That's a manufacturer's rebate as well. I want to thank you for everybody for your time. Again, if you're interested in joining NABCEPT, our pre-event, please shoot me an email, and everybody will get a copy of this. Thank you again, and we'll see everyone the next time.